How's it going, everyone? Today we're going to be talking about renal physiology, specifically a renal artery stenosis practice question. These types of questions can be really difficult if you haven't seen them before, so feel free to pause the video, try it on your own, and then we'll go through it. So a 78-year-old male presents with worsening headaches and a blood pressure of 190 over 110 despite adherence to multiple antihypertensive medications. Imaging shows significant narrowing of the left renal artery. Which of the following physiological changes is most likely contributing to this patient's condition? So I made this question just a little bit harder than what you might see on test day to prepare you a little bit. But we have to basically think about the physiology of this in relation to the anatomy. So how we get blood to the kidney is we're going to take our renal artery, which is going to come off the aorta, and that's going to narrow eventually into an afferent arteriole. And that afferent arteriole refers to the arteriole that's feeding into the glomerulus, which is a tangle of capillaries that's going to filter things through Bowman's capsule. So here's Bowman's capsule here, and then we're going to have eventually an efferent arteriole. It's going to take blood away from that glomerulus. Now what's going on in renal artery stenosis is basically we've got some atherosclerosis here. We've got fatty plaque buildup in the renal artery, the same plaque that can cause coronary artery disease. So we're basically clamping down on this part of the renal artery. So what was really confusing to me as a student was, doesn't this mean that the pressure is actually going to be higher in the afferent arteriole? Well, that's actually not quite the case. The case is actually that in the afferent arteriole, there's reduced local blood pressure. There's reduced fluid because we're blocking everything that's coming from over here. So for reducing that pressure, the juxtaglomerular cells in the afferent arteriole are actually going to sense that there's low perfusion pressure, or in other words, low pressure to the glomerulus. So that's one way that the juxtaglomerular apparatus is going to say, maybe we need to raise our blood pressure, because its only way of knowing what the blood pressure of the whole body is based off of whatever pressure is right here. Because even though the pressure is high out here, he has a blood pressure that's very elevated, the afferent arteriole is going to sense a local low blood pressure. Okay, so that'll be a problem that we'll show here in a little bit. And then further, the nephron loops back on itself. And in the distal convoluted tubule, which is going to be somewhere around here, we also have macula densa cells, which are part of that glomerular apparatus. And those macula densa cells are going to sense reduced sodium delivery to that distal convoluted tubule. That's another sign that it's sensing that there's a low perfusion pressure or low blood flow to this glomerulus. And it thinks that that's due to the blood pressure in the overall human being too low, when in reality it's due to this renal artery stenosis. So these two things, reduced sense of perfusion from the juxtaglomerular apparatus, as well as reduced sodium delivery by those macula densa cells, is going to cause the increase in release of a hormone that we call renin. Now, renin's job is to catalyze the conversion of angiotensinogen, which is a proenzyme released by your liver, into angiotensin, specifically angiotensin 1. Now eventually angiotensin 1 is going to go on to create a cascade of events that's going to help raise our blood pressure. We don't need to go over all the nitty-gritty details, but you should remember overall for the MCAT's really high yield to know that the RAAS system, the renin-angiotensin-aldosterone system, is for raising blood pressure. And why are we trying to raise the blood pressure if his blood pressure is already high? It's because this sensing system doesn't know any better. Because this is clamped off, it's sensing a low blood pressure after everything that's been clamped off, even though the rest of the body has a high blood pressure. So let's go through the answer choices. Decreased sodium delivery to the macula densa, resulting in increased renin release. Well, that's true. That's actually one half of the equation that we talked about. Those macula densa cells are receiving less sodium because the less overall stuff is getting to the glomerulus. So that sounds like a good answer and turns out to be our right answer. B, increased sodium delivery to the macula densa, resulting in decreased renin release. This is the opposite of what happens. We get reduced sodium delivery due to the clamping down of that renal artery. C, juxtaglomerular cells sensing increased renal perfusion, resulting in increased renin release. So it does increase renin release, but the juxtaglomerular cells here are sensing decreased renal perfusion. Remember, they're here, they're going to be downstream of this occlusion. And then D, elevated blood pressure triggers renin release as a compensatory mechanism. That's going to be the opposite. We actually release things called natriuretic peptides, and for the MCAT, the number one highest yield one that you're going to want to know is atrial natriuretic peptide, or ANP. And that's actually released by the atria of your heart when you get a stretch in the atria of your heart. The ventricles of the heart also release something called brain natriuretic peptide, or BNP, but that's less high yield than MCAT. So that's one of our compensatory mechanisms for high blood pressure. RAAS activation is a compensatory mechanism for low blood pressure. So if you can understand this, you'll be able to net a few more points, especially if you're already a high scorer on the MCAT.